Chapter 7, Part 2, Part B. First part of Chapter 7 was multiplying, and now we're going to reverse the process, and we're going to factor. We're going to turn addition and subtraction problems into multiplication problems. So we always start off with this hierarchy. Is the expression in standard form? In this case it is. N squared is going to come before n. The next thing, is there a common factor? Yeah, there is a common factor here. We have an n that we can factor out, and then we are done in this case because we cannot factor n plus 1 any further. So we are just going to go through this same process each time. Is it in standard form? Yes. Is there a common factor? Not in this case. Is it a special case? Is it a binomial square? It does have 3 terms, but the third term is not positive. So remember, binomial squares has this, 3 terms. Third term, positive. First and third are perfect squares, and the middle equals 2 times the square root of the first times the square root of the last. So we're not going to go into those more than this first example. And then the other special case is the difference of squares. Difference of squares has 3 things. Binomial square has 4. Difference of square has 3. Difference of squares is 2 terms. That's why we didn't test this, because this is 3 terms, and difference of square is always 2 terms. Subtraction, and both perfect squares. So you'll notice that in the special cases, your first and third are always going to be perfect squares. So 5 is not a perfect square. Another reason why we can automatically skip it. So we go to step 4, which is A times C. That doesn't look like an A times C. A times C. A, when we talk about A times C, this is the first example. Again, I will take the time to explain. Whoa, where'd you go? I will take the time to explain this right now. A times C, I'm talking about the quadratic template of A squared, A times x squared plus bx plus c. So where my A value is the coefficient of x squared, which would be 1 in this case. That's not a very good one. 1. B would be the coefficient of n, and c is going to be the constant. So when I say A times C, I'm talking about 1 and negative 5. So 1 times negative 5 is negative 5. We're going to do factors of that 5. The signs are different when we have a negative. We're going to look here at our third term. If that is negative, that means the signs are different, because the only way you can get a product of negative is if they're positive negative or negative positive. Then we look here and we see that the bigger of the outside and inside is going to be negative. So these are our outside and inside. The bigger is negative, and the signs are different. So the signs have to be different from each other, and the negative will get the bigger of the 2 numbers. And we're going to simplify that to negative 4. Does this equal my middle term? My middle term is negative 4. Yes, it does. So these are my outside and inside. Those are my outside and inside coefficients, positive 1 and negative 5. So I'm going to turn this trinomial into a polynomial by using my outside and inside. I'm going to write plus, we'll say plus 1n. I don't like that, but I'll do it just for this example. Minus 5n minus 5. So I'm just turning my middle term into the outside and inside right here. And I got those 2 numbers from these factor pairs. Now I'm going to factor by grouping. When we factor by grouping, we're going to look for the greatest common factor of these 2 groups. First 2, we see that we have a greatest factor of n. If we factor in n, we get n plus 1. If we factor out of the second group, My first term is negative. First term is negative. I know I have to factor out a negative 5. This leaves me with n plus 1. How do I know I got it correct? Because these binomials will be the same. I'm going to factor out the n plus 1, and that leaves me with n minus 5. And that's how we do A times C. Now we're going to do them a little bit faster. Oh, you should already know what this is going to do. So is it in standard form? Yes. Is there a common factor? No. Is it a special case? Yeah, difference of squares. Two terms, subtraction, and both perfect squares. Yep, two terms, subtraction, both perfect squares. So we're going to create conjugates. Conjugates are identical with different signs. So we're going to take the square root of my first, that becomes my first, square root of the last, that becomes my last, and then we're going to do opposite signs. It's as easy as that. Standard form, common factor, no. Special case, no. 15 is not a perfect square, so we can just jump to A times C. A is 1, C is 15. Factors of 15 are 1 and 15, 3 and 5. My signs, when this is plus, that means my signs are the same, because the only way you can get a positive through multiplication is if they're both positive or both negative. We look here and we see that they're both positive. So I'm going to take my factor pairs and I'm going to give them the positive, both positives. I'm going to combine them, I'm going to add them, and which one equals my middle? 8 is my middle, so this is going to be my outside and inside. So we're going to rewrite this, r squared plus 3r plus 5r plus 15. Remember, this must equal this. That's why I knew the variable was going to be r's. Now I'm going to factor by grouping. I'm going to group the first two, group the second two. I can factor out an r from the first two. That leaves me with r plus 3. I'm going to factor out a positive 5 from the second group. That leaves me with r plus 3. I knew I did it correct because they were the same. Those must be the same. And if we pull out the r plus 3, we're left with r plus 5. You can check that by multiplying that back out, and you should get your starting expression. Standard form, yes. Common factor, no. Special case, kind of looks like a binomial square. Oh, because the first and third were perfect squares, but remember my third term has to be positive. So not a binomial square. Negatory. So we'll do A times C. A is 1, C is negative 36. Multiply those two. That's why we say A times C. And now we find factors of 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 no, 6 and 6. Signs are different, and the bigger is positive, the bigger of the two factor pairs. So bigger is positive. All of my numbers on the right side are going to be the bigger of the two. All the numbers on the left side are going to be the smaller. And since the signs were different, I had to make them opposite signs of each other. 35, 16, 9, 5, 0. Which one equals my middle? 5. So that's these two. So I'm going to rewrite it. Negative 4 and 9, negative 4x plus 9x minus 36. I'm going to group, factor out an x, that leaves me with x minus 4. Factor out a 9, that leaves me with x minus 4. Let's pull out that x minus 4, and you get x plus 9. If you can do it that fast, you're going to do well this weekend. Standard form, yes. Common factor, close, but no, 7 doesn't go into 60, nor does it go into 64. So, but 64 and 60 did. Special case, no, 7's not a perfect square. 4 is A times C. Hiya, 7 times negative 60 negative 420. Factors of 420. Oh my goodness, we're going to be here for all day. 3, yes. 3 is going to be 140. 4, yes. 4 is going to be 1055. 5, yes. 5 is going to be 84. 6, yes. 6 is going to be 70. 7, yes. 7 and 60. 8, yes. 8 and 8, no, not 8, sorry. 9, no. 4 plus 2 plus 0 does not equal 9. 10, yes. 10 and 42. 11, no. 12, yes. 12 and 35. 13, no. 14, yes. 14 and 30. 15, 15, no. 16, no 8s. 16, 17, 18, 20, yes. 20, 20 and 21. 20 and 21, yeah. Yes, and that's it. Now we're around the horn. My signs are different. My signs are different. Negative means signs are different. I'm not talking about looking at both of these signs. We never look at both of those. I'm just looking at that first, and now I know they're different, and the bigger is going to get that sign. So biggers are on the right. Bigger, 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 bigger. Woo, that's a lot of factor pairs. Positive because they're going to be different. Because they're going to be different. And now, instead of doing all those, I need it to be 64. So which one of these subtracted is going to give me 64? Which one? Oh, this one's going to give me negative 64. So I know that my answer is going to be this, positive 6, negative 70. Positive 6, negative 70. I'm going to factor by grouping. I can factor out an A. That gives me 7A plus 6. I'm going to factor out a negative 10, which gives me 7A plus 6. 7A plus 6 times the quantity A minus 10. Yeah. All right, that was long. 1. Oh, so close again. 28. All right, 1. Standard form. I was already skipping steps. Common factor. No. So close. 3. Special case. 9's a perfect square, but 3 is not, so no. 4. A times C. A is 3. C is 9. 27. 1 and 27. 3 and 9. And that's it. Signs are the same. Both are positive. So that's my 28 for my middle. So I'm choosing these. 3r squared plus r squared plus 27r plus 9. We'll factor out an r. That gives us 3r plus 1. We'll factor out a 9, which gives us 3r plus 1. Quantity of 3r plus 1. R plus 9. Nice. Standard form, yep. That's a horrible 2. Common factor, yes. They both have an x. 7x minus 6. Nothing else can be factored from there, so this is my answer. I'm done. Standard form, yes. Common factor, nope. Special case, no. A times C. You should be moving this fast through the problem. 3 times 6 is 18. Factors of 18, 2 and 9, 3 and 6. Signs are the same. Both are positive. We need them to equal 19. That's this one. There are my outside and inside. 3n squared plus n plus 18n plus 6. Factor out an n, we get 3n plus 1. Factor out a 6, we get 3n plus 1. 3n plus 1 times n plus 6. Number 10 of 31. Standard form, yes. Common factor, no. Special case, no. A times C. 2 times -5 is -10. 1 and 10, 2 and 5. Signs are different. Bigger is positive. That's 9, that's 3. That's my middle term. 2x squared minus 2x plus 5x minus 5. Factor out a 2x. Ooh. You get x minus 1. Factor out a 5, positive 5. You get x minus 1. X minus 1, 2x plus 5. That was a good one. I like factoring out a common. Standard form, common factor, special case, A times C. Well, there's another biggie. -35 equals 38, 21, -210? 35 times 6, 210. Okay, -210. Let's write that properly. 1 and 210. Did I just do 210? 2 and 105. 3 and 70. Signs are different, and we're going to need them to make 11. So I may, I may stop short. No 4. No 4. 5. Yes. 5 and 42. 6, yes, 6 and 35. What am I making? 11. 7, no. 8, no. 9, no. 10, yes, 10 and 21. And signs are different. Bigger's negative, makes -11. Those are my pairs. So I don't have to do all the other razzmatazz. Positive 10, -21. Positive 10, -21 minus 35. Factor out a 2v. That's 3v plus 5. Factor out a -7. That is 3v plus 5. Yeah, that worked. 3v plus 5. 2v minus 7. Ooh, look at that factor pair. Look at that binomial. Oh my goodness. Do you see what you're going to multiply? All right, this probably took you a little homework time. Not a special case. A times C. Mr. Mac is a cruel person. 12, 42, 43. 1, 4, 32. 2 and 2, 1, 6. 3, 7, 8, 9. Yeah, 3 goes into that. 1, 4, 4. 4 goes into this. 4 goes into 108. 5, no. 6, yes. 6 goes into 72. 7. I feel like 7 should go into it, but no. 8, yes. 54. What are we doing? Signs are the same to make 43. Nope, we're not close yet. 7, 8, 9, yes. 9 goes into that. 9 goes in, not 7. 9 goes in, 4 is 36, 72, 48. Close. Next one's going to be 10, no 10, 11, 12. Yes, 12 and 36. 12 and 36 make 43. What? 43. You think we got one more set? 14, 16, 16 and 27. Does that make 40? There's my 43. Signs are the same, both are negative, which makes -43. Whew. Wow, okay. -16, -27. negative 16, negative 27, did we say? Negative 27. That's a bad negative. Negative 27n plus 72. Let's factor out a 2n. That gives us 3n minus 8 minus 8. Let's factor out a negative 7. And that gives us, negative 9 gives us 3n minus 8. There you go. 3n minus 8, 2n minus 9. Oh, we got 31 of these. Oh my goodness, no common factor again. Well, this is why Mr. Mac gave you so many of these problems. We're only on 13, and it's 4:30. I have a charity event I have to go to at 6 o'clock. Common factor, no. Special case, no. A times C, 8 times negative 18. 64, 6, negative 144. 8 times 18, 144. Negative 144. 1 and 144, 2 and 72. 3, yes, 3 and 48. 4, yes, 4 and 36. 5, no, 6, yes, 6 and 24. 7, no, 8 and 18. 9, yes. 9 and 16. And 12 and 12. Signs are different. Subtraction, bigger is negative. This gives me my negative 45. 3 and negative 48. 3, positive 3v, negative 48v minus 18. We're going to factor out a v. That gives us 8v plus 3. We're going to factor out a negative 6, which gives me 8v plus 3. 8v plus 3, v minus 6. We'll get there. Standard form, yes. Common factor, no. Special case, no. A times C. 9 times negative 40. You probably don't like me very much for these huge numbers. Minus 360. 1 and 360. 2 and 180. 3 and 120. 4 and 90. 5, no. Oh, 5, yes. 5 and 72. 6 and 60. 7, no. 8, yes. 8 and 45. 9, yes. 9 and 40. 10, yes. 10 and 36. 11, no. 12, yes. 12 and 30. 13, no. 14, no. 15, no. 16, no. 17, 18, yes. 18 and 20. And there we are. Signs are different. Bigger is negative to make 37. 37? Bigger is negative. I think that makes negative 37. Yep. 8 and negative 45. 8 and negative 45. We're going to factor out just an m. We get 9m plus 8. We're going to factor out a 5, a negative 5. And that gives us 9m plus 8. So it's 9m plus 8, m minus 5. We have 1 standard form, 2 common factor, nope. 3 special case, 4 is going to be A times C, 6 times 36, again a huge number. That's going to be 36. That's going to be 18. That's going to be 216. 1 and 216. 2 and 108. 3. Yes, 3 goes into that. 3 goes into it 72 times. 4. Yes, 4 and 54. 5, no. 6, yes. 6 and 36. Yeah, there's our pair. 6, 7, no. 8, yes. 8 and 27. 9, yes. 9 and 24. 10, no. 11, no. 12, yes. 12 and not 12 and 12. 12 and 18. Signs are the same to make 35. To make 35. To make 35, that equals 35. So 8 and 27. 8 and what do we say, 37? 27. Factor out a 2x. You get 3x plus 4. Factor out a 9? Yes, a 9, and that's 3x plus 4. 3x plus 4 times the quantity 2x plus 9. Can't say that you aren't going to be proficient at factoring polynomials after this worksheet. Hey, look what we can do! Standard form. Number 2, common factor. Yes, we finally have a common factor. Yay! We can factor out a 6. That leaves us with b squared plus 10b plus 16? Yeah, 16. Now we continue on. Special case. Is this a binomial square? Oh, that's so close. 3 terms. Third term is positive. First and third are perfect squares, but unfortunately, the middle, 10b, does not equal 2 times the square root of the first times the square root of the second. That's 2 times b times 4, which is 8b, which does not equal 10b. So not a binomial square. So close. So we just go to a times c. And a is 1, c is 16. We're using this. We're looking at this a times c. This 6 is a factor. It stays outside there. It just is coming along. It's like a barnacle on a bridge. On a, what would we call that? A pier post. 1 and 16, 2 and 8, 4 and 4. Signs are the same, both positive, and they need to make 10. There's my pair. So 2 and 8. So we bring this 6 out there. B squared plus 2b plus 8b plus 16. And now we're going to group again. We don't change anything. We're just pretending to write this each time. I'm going to write brackets because you're going to factor out a b. And that leaves you with b plus 2. You're going to factor out an 8. That leaves you with b plus 2. And now we did it correct because we have b plus 2. So that's 6 times b plus 2 times the quantity b plus 8. So that coefficient, that 6, goes out in front like a coefficient. So standard form, yes. Common factor, yeah. And even if there wasn't, we can't have a first term negative, so we would have to factor out a negative even if there is no multiple of the constant. But we can factor out a negative 4. That leaves us with m squared plus 9m plus, not 9m, sorry. Yeah, 9m plus 8. Now, special case, no. A times c, yes. A is 1, c is 8. Factors of 8 are 1 and 8, 2 and 4. Signs are the same, both positive. That's my grouping. Negative 4 times m squared plus m plus 8m plus 8. Factor by grouping, -4. We're going to factor out an m. That leaves us with m plus 1. We're going to factor out an 8. That's m plus 1. We get -4 times the quantity m plus 1 times the quantity m plus 8. Standard form, yes. Common factor, yes. We have a common factor of 3. That's p squared minus 16p plus 64. Good. Is it a special case? Let's check and see. Binomial square, 3 terms. Yes. Third term, positive. Yes. First and third, perfect squares. Yes. Does the middle, 16p, equal 2 times the square root of p squared times the square root of 64? 2 times p times 8. 16p equals 16p. That means it is a binomial square. Yes! So we are going to, that's a binomial square. We're going to take the square root of our first, square root of our last, and we're going to take down this negative. And that is the answer. People get a little confused on whether I carry that square. I don't know why they wouldn't think I would carry the square. Of course I would. Of course I would include the square. It's a binomial square. Has to simplify back up. Ooh. Has to simplify back up to the starting problem. That would be my answer. I would not write p minus 8 times p minus 8. I would write it as the quantity of p minus 8 squared. Nice. Whew. Standard form, yes. Common factor, yes. -4. You get x squared plus 10x plus 16. Is that another binomial square? No. 4 and 4 is 8. So this is not a binomial square. So it's not a special case. A times c. 1 times 16 equals 16. 1 and 16, 2 and 8, 4 and 4. Signs are the same. Both are positive. There's my 2 and 8. I think I've done this before. -4 x squared plus 2x plus 8x plus 16. Factor by grouping. -4. We're going to factor out an x. You get x plus 2. Factor out an 8. You get x plus 2. Mr. Mac has been on his feet all day. My dogs are kicking. I can feel my feet. When you can feel your feet, you know you've been on your feet a lot. All right. We're keeping it going. We got 11 more. Standard form, yes. Common factor, yep. Take out a 3. That leaves us with x squared plus 5x minus 50. Pretty sure it was 50. Yes. 3. Special case, no. 4. A times c. Do you already see what the a times c is? A is 1. C is -50. Signs are going to be different. 1 and 50. 2 and 25. I already know what it's going to be. You know it's going to be 5 and 10. Signs are different. Bigger is positive. To get my 5 as my middle. So if you can see that, don't be afraid to jump to that step. If you can see what the answer is, but you better check. You better check. If you're going to not show work and you're just going to write an answer, there's no excuse for you not checking your answer. There's no excuse for not having the right answer, unless you have no idea what you're doing. Standard form, common factor, yes. We're going to factor out a 16, 16a, and we get a minus 10. Can't be factored. We are good to go. That's it. Let's get more of those. Wouldn't that be nice? Standard form, yes. Common factor, yes. We have 8 goes into it. So I'm going to start with 8. That leaves me with, 8 doesn't leave me with, 5a squared minus 8, 9, 16, so that's 1. A 12 is 68. No, 60. Use your calculator. 148 divided by 8. No, it's not 8. It's 4. 4, which is 10a squared minus 37a minus 12. Okay. And now we can look here and see, did I take out the greatest common factor? Yes, because no number goes into 10, 37, and 12. So we're at special case, not a special case. A times C is 10 and negative 12, negative 120. 120, 2 and 60, 3 and 40, 4 and 30, 5, no, oh yes, 5 and 24, 6, yes, and 20, 7, no, 8, yes, 8 and 15, 9, no, 10, yes, 10 and 12. Look at how fast you can do factor pairs. Signs are different, bigger's negative to make 37. To make 37. So positive 3, negative 40, positive 3, negative 40. Let's factor out an A, that's it. A is 10A plus 3. Factor out a negative 4, which is 10A plus 3. We get 4 times 10A plus 3 times the quantity A minus 4. Give that problem to any other high school student outside of American Martyrs, and they're going to take forever to do it. Not my kids. My kids will be able to rattle that off, baby. Standard form. Let's check the phone, make sure nobody's looking for me. 4:45. Here we go. Can I get it done by 5 o'clock? Not if I keep talking and doing things that aren't common factor. Yes. Negative 3. Negative 3. That's going to give us 9x squared plus, that is 119x plus 224. Is that true? Those are some weird, oh, that needs to be negative 24. Almost made a mistake. Thank goodness I stopped and took my time. Special case, no, close. 9 is a perfect square, but 24 isn't. A times C, 9 times negative 24. 36, 18, 21, negative 216, 1, 216, 2, and 108. I feel like I've done these before. 3, yes, 72, 4, yes, 4 and 54. Signs are different, and we're going to be subtracting. 5, no, 6, yes, 6, and 36, 7, no, 8, yes, 8, and 27, 19. There it is. Signs are different. Bigger's positive. 19. Positive 19. So we got negative 8 and 27. Negative 8 and 27. We're going to factor out an x, which gives us 9x minus 8. We're going to factor out 3. Positive 3, which gives us 9x minus 8. Negative 3 times the quantity 9x minus 8 times the quantity x plus 3. Yeah. Yeah. Who's not going to be ready for their placement test? Oh my God, look at this problem. Standard form, yes. Common factor. First term is negative, so we got to pull out a negative and a 5. Can we do 9? No, 5. 9m squared plus 226m minus 40. Close on that perfect square again. Special case, no. A times c, 9 times negative 40 equals negative 360. Barf aroni. Too bad we can't cut and paste these factor pairs because I feel like I've done them. Subtraction to make 26. 2, 180. I don't know. 3, 120. 4, 90. 5, yes. 5 and 72. 6, yes. 6 and 60. 7, no. 8, yes. 8 and 45. 9, yes, and 40. Not 9 and 40. 10 and 36. 10 and 36. Oh, there it is. 10 and 36. Signs are different. Bigger's positive. Whew, negative 10 and 36. Negative 10 and positive 36. Negative 5. Let's factor out an m. We get 9m minus 10. Let's factor out. Oh, let's factor out a 4. That gives us 9m minus 10. We get negative 5 times the quantity 9m minus 10, m plus 4. My handwriting is dying. Oh my goodness, Mr. Mac, why'd you make those numbers so big? I actually could have kept them small. Common factor, yes. 268, come on, Mr. McCausland. You're killing me here, Smalls. You're killing me, Smalls. 4. Let's check it. Yo. Minus 67a minus 40. We got 360 again. Not special case. A times c. 9 times negative 40. Negative 360. 1 and 360. 2 and 180. 3 and 120. 4 and 90. Subtraction to make 6. 5. Yes, 5 and 72. There it is, 5 and 72. Signs. That gives me negative 67. Didn't have to go that deep. 9a squared plus 5a minus 72a minus 40. Let's factor out an a. That gives us 9a plus 5. Let's factor out a negative 8. That gives us 9a plus 5. That is 4 times the quantity 9a plus 5, a minus 8. Home stretch. Let's go. I wish they got easier. Standard, yes, standard form. Oh, now we have variables on both sides. Yeah. Common factor. Yeah, 4, I think. Let's hope 4 goes into it. A squared plus 16ab plus 63 b squared. That's a really poor job. 252. 2552 divided by 4, 63. Good. Special case. No, close. 4. A times c. A is at least 1. C is 63. So we have 1 and 63. 2, no. 3 and 21. 7 and 9. Signs are the same. Both are positive to make 16. Okay. That wasn't too bad. A squared plus 7ab. Look at that variable, plus 9ab plus 63b squared. So be careful of that. 4. We're going to factor out an a, which gives us a plus 7b. We're going to factor out a 9b. Very, very technical and tricky right here. A plus 7b. So stay focused. This is the longest part. 9a, 7b. That's a horrible b. You're in the long run. You've been working all night. Stay focused. Stay on the track, just like on a test. Last couple ones at the tail end, don't start making silly mistakes. Standard form, yes. Common factor, yes. There's a 5. You get x squared minus 9xy plus 18 y squared. 18 is not a perfect square, but that's correct. So not a special case. A times c, 1 times 18 is 18. 1 and 18, 2 and 9, 3 and 6. Signs are the same, both are negative. Makes my negative 9. 5 times the quantity x squared minus 3xy minus 6xy plus 18y squared. Let's factor out an x. You get x minus 3y. Factor out a negative 6, and you get x minus 3y. So my answer is 5 times the quantity x minus 3y times the quantity x minus 6y. I got sloppy. That's a minus. You got to factor out a negative 6y because there's a y that is in common in both of these terms. Almost made a mistake. Caught it. I caught it. Standard form, yes. Common factor. Yes, there is a common factor of 5. You get 5x squared. Let's move you over a little bit. I'm getting a little crazy. I'm getting a little stretchy here. 5x squared minus 48xy plus 27y squared. Special case, no. Common a times c. Well, we're back to big numbers again. Gah. 35, 135, 135. That's right. There aren't going to be too many. 3, yes. 3 and 45? Yeah. 3 and 45. Did that real quick. 4, no. 5, yes. 5 and 27. We knew that. And then 9. 9 and 9 and 15. Signs are the same. Both are negative. I shouldn't have even moved past this. 5 times the quantity 5x squared minus 3xy minus 45xy plus 27y squared. Factor out an x. That gives us 5x minus 3y. Factor out a negative 9y. Didn't make that mistake this time. And that gives us 5x minus 3y. We get 5 times the quantity 5x minus 3y times the quantity x minus 9y. Okay, 3 more. Oh, look at this nice gentle one. Standard form, yes. Common factor, yes. Negative 5x, which is 7x plus 9y. Oh, that is so nice. Whew, how relaxing was that one? 2 more. Oh, they gave us a big one. 2. Come on. 4:57. Oh, I'm not going to make 5 o'clock. Common factor. Well, it's not an even number. So factors of 24. 6? 6 go into these? Or is it nothing? Oh, imagine if it was nothing. How not happy would you be with me? Oh my goodness, 171 divided by 6. Oh my gosh, 3, 7, 8, 9. All right, 3 at least goes into it. Oh. Yeah. So let's factor out a 3. You get 8x. 3 is going to be 557 xy. And this is going to be negative, no, that's positive 57 xy. Let's move you over. Let's move you over again, sorry. 3 goes into 16, 5, 56, y squared. Yeah, okay. No other number goes into those, so I was correct. No special case. A times C. A is 8, C is negative 56. We're going to jump to calculators. 8 times 56, 448. Negative 448. When they subtract to make 57. 1, 4, 4, 8, 2, 2, 2, 4, 3, 3, no, nope, 3 doesn't go into it. 4, 1, 1, 2, 5, no, 6, no, 7, no, 8, yeah, 8 and 56. Is this going to be unfactorable? Is that all we do? Is that all we do for this one? No. I made a mistake, right? That was 30, yeah. We definitely factor a 3. We definitely factor a 3. Did I do that wrong? 3 times 8 is 24. Let's do, what is 171 divided by 3? 57. What am I doing? 2, 4, oh, 16. 16 and 28, right? Yeah, 16 and 28. There it is. Signs are different. No. What am I doing wrong? What am I doing wrong? What am I doing wrong? Did I multiply that number wrong? Am I forgetting a number there? Signs are different. Signs are different. Bigger is positive. So, a 171. Hello. Oh, no. 57. This is plus 3 gives you 171. That's correct. My brain is melted. I've just absolutely melted. Oh, I guess 6 must go in there. Oh, 56. 56 is 7. 7's in there. Missed. Of course 7's in there. Sorry. 7. 7, Mr. Mac. Sorry. 7. 7. Oh, Robert. 7. 7 goes into that. 6. 64. Betcha. Yeah. My bad. Signs are different. Bigger's positive, minus. Yeah, my brain's fried right at the moment. Your brain's fried, Mr. Mac. You made me do this problem all the time. And you're really good at it. Just think about how much it took me to do it. Yep. But you're that much better now, aren't you? How do you know you've lost your mind without telling me you've lost your mind? When you talk to the smartboard. What's that going to be? That's going to be 8y, and that is going to be 8y minus wow, my brain. 7. Oh, okay. I was like, is this a binomial square? No, they're not. They're close to each other. 3 times the quantity 8x minus 7y times the quantity x plus 8y. Why couldn't you just do that, Mr. Mack? You labored on that problem so much. All right, here we go. Standard form, yes. Common factor, yes. Negative 2. You get 10x squared minus 7xy minus 63y squared. Special case, no. A times C, yes. 10 times negative 63, negative 630. Signs are different, makes subtraction. 1 and 630, 2 and 315, 3 and 210, 4, no, 5, yes, 5 and 1, 2, 6, 6, yes, 6 and 105, 7, no, oh, yes, 7, 7 does go into that, 7 and 90, right? That's equal 7, huh? Okay. Subtract, so we're going to get really close. Well, 10 and 63, and we got to get down there. We got to get to 12, no, 14 and 35. No, that's not going to give me 7, so we got to keep going. Here's another way. So let me show you another way. Kitties. You can do prime factorizations. 18, 14, I mean, you can do 21, right? 21, 20 and 21. Oh, is that really give you 20 times 21? No, that's going to give you 42, 420. 420, not 630. 30? 30? Mr. Mack is, it really, my brain is, so 2 times 5 times 7 times 3 times 3. Those are the prime factors, so can we get two numbers that are 7 apart from each other? 7 apart from each other, that's 10, that's 9, no, that didn't work. So we can do 21 and 15 and 30. So 21 times 30 is 9 away from each other. Oh my gosh, 21 and 30. So this is 9 away, so we got one more increment to go to get closer to 7. So what's that, 22? No, 22, does 22? No, 23, 24? 24? No, it's not 24. Oh man, my brain is not working. 6:30 again. So what did we say? 7 times 9, right? 7 times 9 is 6:30. Yeah, 7 times 9. So 70 times 9, no, but that's not it. So 7 times 90, which is 7 times 3 times 3 times 2 times 5. Yeah, those are my prime factorization. I can use those to help me. That's 21, and that is 30. Yeah, we already did that, sorry. So let's do not 21, let's do 35 and 18, no. 6, oh, 12 and 35, no. Let's do 18. No. Oh, I stuck this for you for our last one, and we are just 15. No, we've already tried that. So let's do this. It's after 21. So this is 21. So 7 times 35, but it's not 6. 50 and 35. No. Did I even do that part right? Yes, 14. Oh man, I apologize. I'm sorry. I gotta make a 7, huh? I gotta make a 7. I know you are already seeing that. So this is where this could become a problem. This could be 2, 3, 3, 5, 7. I'm going to put them in numerical order so I can be systematic about it. 18 and 35, no. 15 and 30, and 21, we've already done that. So 2, 3, 2, 5, 2, 7, 14. Nope. That's 21. That's, yeah, I'm really, that's 15 and, nope. I really am struggling with what the numbers are going to be. What is that pairing when subtracted equals 7? Oh, so it has to be after 21 because this equals 9. So we know that those descend until you get, so 21 is 7 times 3. So what is the next pairing that is up there towards? That's 9 and 2, no. 9 and 5, so what am I looking for? 21. I'm looking for more than 21, right? 21. 21. What's the next multiple? That's 6. No, 18 is not more. That's 6. That's 42. That's too much. So 10, 30. We did 30. 30 and 21. Nope. So 2, 5, and 7. No. 2. No, that's 35. Yeah. Coming. All right. I'm ending it. You'll see the answer on the answer key. I got to go. Good luck.